Now let's take a look at this figure 15-8. It deals with three-phase circuits. We've looked at single-phase circuits. Now let's see how the voltage drop would be calculated for a three-phase. Now in the example, using the resistivity method here, to determine the voltage drop in size elements of a three-phase feeder having the following characteristics. 3%, we want to hold the voltage drop to 3%. It's a 480 volt, 277 volt system. 700 feet. Load is 180 amps. The overcurrent device is 200 amps. And conductors are 4 alt. So let's take a look now at our step 1. Again, looking at 215.2A1, informational note 2, we hold to 3%. Step 2, we're actually calculating the voltage drop, so we look at 215.2A1, informational note in Table 8 to Chapter 9, and we insert values into this voltage drop, 2 times R times L times I divided by 1,000. So 2 times 0.0608, the 4 alt resistivity value that we pick up in Table 8 to Chapter 9, using the calculation of 2 times 0.0608 times 700 times 180 divided by 1,000. The voltage drop then is 15.3216. Step 3, we have to apply the 0.866 for three-phase. So, because we have three-phase system instead of a single phase. So voltage drop is equal to voltage drop times 0.866. So the voltage drop then of 15.3216 times 0.866, our voltage drop is 13.269. Now step 4, voltage drop supply voltage, holding it to 3%. We take the 480 times 3%, we need to hold a 14.4. Step 5, verifying and checking the percentage, 215.2A1, informational note 2, the voltage drop divided by the voltage. So we take 13.269 divided by 480 volt, phase to phase now. And we come up with 0.0276, which is 2.76. We're below the 3%. So as the solution says, the voltage drop rating of 13.269 is less than 14.4 volts that we calculated in step 4. So therefore, the 4 alt copper conductor can be used, and we're going to be within the 3% that we wanted to hold the 480 volt three-phase system to, and that's what our figure 15-8 is illustrating to us.